Okay, so we are recording. Let's begin. So for the question that we were referring to last day was the gambler's ruin problem, which we couldn't get time to complete. So the question says that there are two participants in a gambling game, each having so A and B. There are two participants in a game. So each start with a sum of n coins. So it's you can think of it as it's there in a particular gambling area, and then there these two people playing say you're playing a coin game or a card game, whatever they are. So the total amount of coins they have is n, and say A start. This is the number of coin A have or A has. So say that it has I coins in the beginning. So this is the question. What it says? It says that it has I coins in the beginning. So B has n minus I coins. So what is the probability that A wins is what you're told to find. Okay. So given that it starts from some particular starting point I. So if it starts from I, what is the probability that it wins? What is the game that they're playing? If say there's a coin being tossed, and if head occurs, A gets a coin from B. So A goes to A plus 1 on round K win. So if it wins the kth round, it gets one coin and goes to I plus 1. So whenever it goes to n coins, it will win the game. And as soon as it goes to n, B will go to 0. So you can see there's a symmetry over here. A and B can be they can be interchangeable. So you don't need to worry about who is A over is B. We can solve without loss of generality. And say, so it is asked if it starts from I coins, what is the probability that A wins? So this type of a question is generally you need to solve by using something called as recursion. Why? Because you see, you start from the ith state and you want to go to n is equivalent to starting from I plus 1 also. So if you had started from I plus 1, you can relabel it as I, and the same system of equations should hold. Do you agree? If anyone does not agree, please stop me over here, and then we can write it. So the idea is assume that a Bernoulli P coin is used. That is, I'll come to what is Bernoulli P. That is probability of winning is equal to P. That A wins each round is P. Okay, say small p. And probability A loses each round is 1 minus P, and let us write that as Q. Okay, these are the definitions that I'm writing down initially. And now I'm asking, how can I relate this equation as, say, let us define P capital PI as the probability that A wins if it starts from state I. So if it starts from state I, what is the probability that it wins? So any idea what is the probability that it wins? That is B goes bankrupt. Any idea? Okay, nobody is speaking. Am I audible? So how do I go about solving this problem? So let me, if I'm audible, I'll go up and solve this myself. If it, please confirm that you can hear me. Okay. So Pi starts from, say, I coins, then say Pi is the probability that it wins. So if it starts from the ith coin, what are the two options that can happen to it? By conditional. So, yeah, go ahead.
If I'm at coin I, then either I can go to I plus 1 or I minus 1 after the
Correct.
toss.
Correct. I can go to I plus 1 or I can go to I minus 1. Do you agree? Very good. So how can I come to state I? Can you tell me? So up to state I, how can I come? So you understood that I can go to I plus 1 and I minus 1. So the probability that I start from state 1, what is the probability? I say probability next state is I. Is what? If the next state is I can use conditional probability, law of total probability. What? So I have taught you conditioning, right? So the next step is I given previous step is equal to I minus 1 into win, that probability of winning. Yes or no? Are you? So the
Yes.
next, there are two things that I'm doing here. So the probability that it starts from, that is previous step, is I and I minus 1 and it wins. Is one probability, and the other one is probability of previous step is I plus 1 and it loses. And you agree that there is no other probability than other than these? Only these two conditions are possible?
হ্যাঁ, ওটা তো আগের
Yeah.
দিনের ওই P
Yeah,
of A.
please. There are people who don't understand Bengali, so please, and please speak in English.
So it is from the earlier test it is that P of A is equal to P of A such that
Given it.
some B into P of B plus P of
Yeah.
A such
Same
that
thing.
P
So
of
you're
C.
just conditioning on writing as a total probability. So these are independent, right? So you start at I plus 1 and you win. They are not dependent on one another. So that coin toss happens irrespective of which state you are in. So the idea is the probability that you start at I plus 1 is P minus 1. Do you agree? And this is Pi as we have defined. And you win is with probability P. This is a constant and Pi is the function. Similarly, if you start from Pi plus 1 and you come back to Pi, that means you have lost. That is probability of 1 minus P, or you can write it as Q. Any doubt in this equation? I guess this is clear. So now this is known as a difference equation, where you write the I in terms of I plus 1 or all the integers. So you can write it in terms of integer numbers. So P of I can be written as, so if we can take, so in normally in differential equations, you take e to the power ix for the solution. But in a difference equation, you take x to the power I as a solution, where x you will try to solve for. So what is the value of x is the thing that you will solve for. So here you will write, so tell me what will be p to the power I minus 1? It will be x to the power I minus 1. P to the power I plus 1 will be x to the power I plus 1. Did you understand? Therefore, I can write x to the power I is equal to p into x to the power I minus 1 plus q into x to the power I plus 1. Or in other words, x is equal to p plus q x square, which is, so you get a quadratic equation, qx square minus x plus p equal to 0. Right? Is this okay? Go ahead and ask if you have a problem at any step. So this is the assumption of Pi. And in difference equation, this is how it works. Just like in differential equation, e to the power ix works. Any doubt you ask? Okay. So what is the value of x? By you'll get 1 plus minus 1 square minus 4pq, right? By 1 minus q. Agreed? This is what you get. Or what am I writing? 2a is 2q, not 1 minus q. Right. So what is this? 1 plus minus p plus q is 1 minus 4pq by 2q. Okay, so you get x as 1 plus minus p minus q, assuming p greater than q. So how did I get that? This is nothing but equal to p minus q squared, which is mod of p minus q. So if I write assume p is greater than q, that a has more, it is more probable to have an heads than a tail. So this is what you'll get. So this turns out to be, there appears to be, so you have two solutions to x. One is 1 minus q plus p by 2q. Other solution is 1 minus p plus q by 2q. Right? So this is equal to 1. 1 minus p is equal to q. And this is equal to p1 by 1 minus q is p. So you have this as p by q. Right? Yes or no? This is equal to p plus p, 2p. So in these cases, so you have two solutions. So I just want you to understand what do you want to write it as. So you can write xi as p1 p by q to the power I, c2 plus c2 into 1 to the power I. These are the two solutions possible. So you take all the linear combinations. These are the steps. It will be clear when I'll show you in linear algebra why is this case. But this is the general solution because you have two solutions to x. So you have all the linear combinations of these two as the solution. So C1 and C2, any ideas how can I solve for them?
I will put the base cases over here.
What are the base cases? Pi is equal to 1 if I equal to n, and Pi equal to 0 if I equal to 0. I'll get two equations and solve for them. So the idea is not to show you the algebra over here. Therefore, I have not asked you many times that you can like this is your. So I showed you now. You know the probability of when A wins as well as the probability when B wins. So this is your second part is your homework where you have to show that what is the probability it never wins. No one wins. So that is 1 minus A wins minus B wins, and you will show that it is never possible. So with almost sheer probability, the game will end irrespective of the value of n and where you start. Okay, this is you can just do the algebra, but for the time being, algebra can be kept aside and please ask me about if you have any doubts regarding the question, regarding any step that you couldn't understand. Yes, it is. Yeah.
Moinakdar, can you please show that C1 and C2 part once?
So as in so there are two solutions for x, right? So we assume that pi is equal to x to the power I, right? If there is,
Yes.
and we got two solutions for x. So the all combinations of x, linear combinations of x is the solution to pi.
Yes.
Because you have two, you will see in linear algebra when you have two basis vectors around which you can solve, all linear combinations would be a valid solution of that. That's the idea.
Mm-hmm. Um, Moinak, the one more thing. So the first step means the first step where you
Hmm.
did that pi is equal to pi minus 1 into p plus
Hmm.
pi minus 1 into q.
Hmm.
So over here pi is the probability that a wins if it starts from state I.
Correct.
Um,
So I should write it more clearly, like probability that A wins start from I. So similarly, I can write, I did not write A wins, but A wins start from I minus 1, right? Start from I plus 1 and you have a, so A wins the round. This should be the, A loses the round.
so we are
Yeah.
just building a sort of a recurrence relation right down here.
This is a recurrent relation, but you're using conditional probability. It's a law of total probability, right? So A wins from state I is equivalent to
Hmm.
saying what are all the joint distributions such that you come back to state I. Or you can
Yes.
just use, or you can just think of it this way. Don't think of it as conditional probability. Think of it as this diagram. You have to come to state I in the next step. So how can you come to state I? So Bromojit told me that from I can go to I minus 1 and I plus 1. So to I, how do I come through I? I can come from
I
with
minus 1 or I plus 1.
correct. It's just the writing the inverse with probability 1 minus p, I'll come to I, and with probability p, I'll go to
Okay.
from I minus 1 and so on.
Hmm. Yes,
I
it's
guess
clear.
that solves most of your problems. And let's now go on to the
Dada,
real
sorry to interrupt. Can you
yeah.
explain the second boundary condition once?
Second boundary condition. Okay, you rest of it you understand it. This is what I need. You just ask me as and when I'm telling you. Uthrij, is it okay? The rest of it is okay to you?
Yes. Yes.
Okay, so you understood we got two solutions to x, right? The quadratic is simple. I used Sridhar Acharya formula and got two solutions where p and q sum to 1. The idea is, so since you have two constants, right? C1 and C2, do you agree?
Yes.
So you need two base cases to get the values of C. So if you start from state n itself, where the person has n coins to begin with, what will happen? How with
Then
what
already
probability will you
one.
win? You have already won, so you can write 1. So probability of n is equal to 1 is equal to C1 into p by q to the power n. Do you agree? Plus C2.
Yes.
I'm just putting the value. So think of it as a function, and then similarly, if I start with 0, do you agree? I have no probability of winning. Similarly, I can write C1 plus C2. I is equal to 0 here. Understood?
Dada means at the beginning he has no coins, but he can win all
Exactly.
the coins back from B. A can win all the coins back from B.
So you are saying, is there a coin? There will be no coin toss if he has 0 coins. That's another base case I should mention. If any, so that's the case already. Now, if you already go bankrupt, you will stop the game. There's no need to explain. Also, you need not write that. If you already go bankrupt, you have won, right?
Oh yes. Yes.
Yeah. So you don't get any more
Uh,
chance at all. Go ahead.
so Moinakda, these n and 0 are
Hmm.
sort of dead states or recurrent
Death
states,
states,
which
yeah.
we,
If you think of it as a Markov chain, then yes.
hmm.
But Markov chains are not a part of your syllabus as well. But you can you can look at my videos of previous time. I had explained Markov chains in great detail. You'll understand that. Okay.
Okay.
Yeah. So now let us begin with the interesting part of today's session. That is, what is a random variable? And here begins the machine learning part of everything. So everything in machine learning is a random variable. You must remember that. So what is a random variable? So the random variable is a, so till now we had defined probability over events. Do you agree? We had only events and we defined probabilities on them. That was all we had done. But events are not numbers and they are difficult to manipulate. Do you agree? We had a set of states, sigma, and we took all subsets and assigned a probability to them on the real number line between 0 and 1. Agreed? This was in one event, and we had assigned a probability between 0 and 1 to all subsets of the sample space. Right? But do you agree that these objects in terms of sets are difficult to compute? If you have to compute the average of those events, what will you do? You will not be able to do any, there's no meaningful operations that you can do. Right? So that's why we introduce the concept of random variable. What is a random variable? So I'll give you a intuition first, and then I'll give you the mathematical understanding. So you say you have a experiment of a coin toss, right? Where you say head is equal to 1 and tail is equal to 0. Okay? You define head and tail as 0 and 1, and x is defined as a random variable as the output of the coin toss or outcome of the coin toss. Okay? Is this clear up to now? So then if I ask you what is the probability of x is equal to 1, what will you say? Say it's a fair coin.
It's half.
How can you say it's half? Why will you say it's half? Because you will say x is equal to 1 only happens when when the event head happens, right?
Hmm.
And then you say it's half. So you see, this is an abuse of notation that I'll be using. What does it actually mean? It is so a random variable is a mapping. So x is a mapping from all these elements in the source set to a real number line. Okay. Do you agree? So if I have a head, say, let us draw it for the coin toss example. If I have head and tail as two examples of the coin toss, so I'll have something like this, isn't it? So head will be point, x will map x to head to 0 or 1 and tails to 0. Do you agree? This is your random variable that we have defined. So do you agree x is a mapping from the sample space to real number line? Or it is a function of that takes an element in sample space and maps to real number line. Any doubt in this? So you have the domain set is your sample space, right? And your range set is your real number line. Okay. Now we have numbers instead of events. And now we can do arithmetic on that or algebra on that. Did you understand? It's a function. X is a function that maps any event to the real number line. So please ask. This is the part where you'll, otherwise the rest of it will not be clear. No doubts? Absolutely clear.
Yes, Bhanuta.
Okay, so it's a so if I ask any one of you, will you able to tell me? So what is see? So let us do an example and then. So if you have really understood, so what would x is equal to 1 mean? How can you write this as? What is the actual meaning of this? I'm writing x is equal to 1. What is the, but you cannot define probabilities on random variables as such. You have to define only probabilities on events. Yes, go Partho.
So it's f of 1 if the function is
Function is the random variable, right?
x of 1.
X of 1, what does it mean? Make it, you mean, so x of head is equal to 1. X of
Oh,
tail
yes,
is
yes.
equal to 0. So head is equal to x inverse 1 and tail is equal to x inverse 0. Isn't it?
Yes.
So this actually means what is the probability of x inverse 1? Or in other words, it means it is the probability of all those events such that x of omega is equal to 1. Do you understand now? So you may have multiple events for which, so x inverse is a set, it's not a function. It need not be a function. It's a set and not a function. Why? So for example, you can have two elements, both pointing to 0. It's a valid function. Then you can have multiple elements in this domain set pointing to the same element in the codomain set, many to one function. Agreed or not?
Yes.
So in that case, inverse operation will contain only both of these.
Yes, and the probability be the union of those
Correct. That's why I have written
events.
it's the set containing all those events such that x of the event is equal to the output or this value, whatever you have got. Right? Remember this. So maybe throughout this course, you will not be using this definition all the time. But as soon as you go into higher studies or anywhere, this will be the major definition you will be using. So, and it's good to remember that random variables probability is not defined over random variables, but over events. It's just a way to simplify things, random variables are. Okay? That's clear, I guess.
Dada, just a question, means
Go ahead.
what number we are assigning to the event means
Correct.
will depend on what?
That will be different depending on our definition. We'll come to those questions. Very nice question, but you understood the concept, right? If you have a function, if I'm giving you a function, what would be the probability to of this random variable taking a value is understandable to you, right?
Yes, almost.
No, if it is not totally, then you ask. I'm trying to like get it as clear as possible. The function, there's only maybe of one thing that you're not understanding that may stop you to understand further. Because calculations we can just breeze over. You can do these calculations, nothing in calculations. And majority of this course will be calculations only. It's the fundamentals that is important. Go ahead, Utriji. Which part did you not understand?
Like this, if any one of the events for which
Yeah.
x is taking 1 happens,
Yes.
then
Yes.
will we call it x equals to 1? Or if all those events happen, then x
Correct.
will be 1.
Very good. So no. So say if x is equal to 1, right? Let us take a concrete example, right? Say A is an event, B is an event, and C is an event, right? With say equal probability 1 by 3, 1 by 3, and 1 by 3. Okay.
Okay.
Now you are saying let us map it to a random variable. Okay. Say 0. Both are being mapped to 0. And this is being mapped to 1. Okay.
Okay.
Right. So now I tell you that x is equal to 1 happened. I tell you this thing that x is equal to 1 happened. What do you infer? then which event occurred? Or x is equal to 0 happened for your, say if x is equal to 0, when can x equal to be 0? When can x be 0?
Then A or B means if any happens, because
Correct. A
both maps.
comma. Correct. X is equal to 0 means it is x inverse 0. Whatever is mapping to it, that is A and B. So your probability of x is equal to 0 would be probability of A comma B, that is equal to 1 by 2 by 3. Right? So x equal to 0 means either of those two events have occurred. So it's the union of these two events, right? So the probability, it has more probability of occurring. It's clear, right? So to z when it is 0, you have more probability of this occurring because A and B both map to the same number.
Yes, understood.
Okay, so let us take one example now, like things that we normally do. Is the first one is called the Bernoulli random variable or a coin toss. This is equivalent to a coin toss. And for the time being, we are considering only discrete random variables. That is, the values of the codomain set is only discrete numbers, not real numbers. They can be only integers, right? So P of this is where I told you where I'll tell you that it is not a fair coin. So if it is not a fair coin, say you'd say probability of x is equal to 1. That means probability of head is P. So probability of tail is 1 minus P. There is no doubt of that. So that x is equal to 1. I'm writing that as or the head I'm writing at x equal to 1. So if you have a success in a trial, you can think of it as a coin toss. You have a P probability of success. On the other hand, you have 1 minus P of probability of success, of failure. Is it clear? So there can be any event. Now you have abstracted the idea of events and sample spaces to random variables. It's just functions now. So x can take values either 0 or 1, and taking one value has a probability of 1 and probability of 0 if it has to take a value of 0. Do you agree? There's nothing. This is the definition of a Bernoulli random variable. So this can be equivalent to a success, and this can be equivalent to a failure. Okay. Good. So if I ask you, that will only be able to appreciate mass function. Why is it called a mass function? Because to every p, I'm giving a probability, right? So the random variable can be at 0 or 1. And I gave probability of half to both of them. Keep this in mind. It may be helpful. So probability of x is equal to k, and this is value of k. Okay. So this is called a PMF or a probability mass function. That you define the probability of a random variable taking a value. If there is a gap here, please stop me, because after this you'll see that you can easily think of things as a random variable and not events. And that may be helpful for rest of the course and also in machine learning.
Dada, can you explain this mass function once more?
Yeah, sure. So I'm saying that, did you understand what is the probability of a head and a tail? So you can have a head and a tail. These are events, right? Or a success or a failure. They are just some concepts, not exact concept. It can be anything. You can win a match. There can be probability P. You can ask that also can have an success and failure, right? So anything can have, these can be events. Of course, they can have a probability of success. 80% of times you succeed, then that is for Bernoulli 0.8, right? So a success failure event, success failure experiment with a p probability of success. So success is mapped to 1 and failure is mapped to 0 using x. So you tell me now, what is the probability of a success or x is equal to 1? I have already told it's a success failure event with x being mapped to success equal to 1. So you have success and failure. So x of success is equal to 1 and x of failure is equal to 0. So the
Yes.
idea, correct. So the probability of, I have already told you the probability of success is p. So what is the probability of x equal to 1?
Yes, you have told it P.
Yeah, so it is p. X is equal to 1 will also have probability p. So do you understand the difference? Like success, instead of using success failure, I'm using x is equal to 1 now as some indicator or something like that. Okay.
Yes.
So now you're telling me, so x can take values 0 and 1. Do you agree?
Yes.
So I need to tell what is the probability that for all of these values that there is a given probability. So it's 1 minus p for 0. So the probability function, it will tell me for every value that the random variable can take, so that is 0 and 1 here, what is the probability of its occurring? Now you can think of these as the events sort of roughly, isn't it? So the p is now a function, do you agree? Which will map from, where will, I told you last day, right? P maps from the events to 0, 1. Yes or no? P is the probability of events. So in our case, the values of the what random variable can take. So this will mark real numbers to 0, 1. Okay. This is what a random variable will do, or a PMF will do in our case. Okay. So if I tell you what is the probability of x is equal to half, you will tell me it is 0, right? Okay. So x taking value 0 or 1 both have probability half in this probability mass function. This is defined for all the cases. You need to define what is the probability, right? Is it clear?
Yes.
Okay. So now I'll tell you why I'm using random variables instead of using directly events. That major event is we need to do statistics with these random variables. Statistics as in what is the mean, what is the mean height of the class, what is the mean weight of the class. So you can think of each of these as random variables now. So x is a random variable of heights. So you can take it as a random variable of being 174. What is the probability? 175 centimeter. What is the probability? And so on. So for the time being, let us tell you what is the average of this sequence. So if I ask you what is the average of the sequence, many of you will tell me it's 1 into 2, or rather let us okay, 1 into 2 plus 2 into 1 plus 5 into 3 plus 7 into 1 by what? 1, 2, 3, 4, 5, 6, 7. Will you tell me this is the average?
Means then we are assuming that all of them are equiprobable.
So there is no probability here. So if you are told to find the average of these sequence, you will tell that this is the average, right or no?
Yes.
By your class 1, 2 definition. This is your average.
Hmm.
Average of all the values. So this is, do you agree this is equivalent to writing 1 into 2 by 7 plus 2 into 1 by 7 plus 5 into 3 by 7 plus 7 into 1 by 7. Do you agree? Now this is equivalent to, as O3 was telling me, what is a probability mass function. So if I assume that this is taken, this is the actual distribution of the data. So you will be able to tell me what is the mass function? Yes or no? So what are the outputs? 1, 2, 5, and 7. Now tell me, O3, what is the mass function? What will be the mass function over here?
Like for 1, it will be 2 by 7 probability. Then
Very
for
good.
2, 1 by 7.
Yes, this is what I want to know. I thought you did not understand. So 1 by 7 and then 5, it will be 3 by 7, right?
Yes, 3 by 7, 1 by 7.
Correct. So this is defined as, so this is known as empirical probabilities or empirical mean. So we will see how empirical mean goes to actual mean in machine learning and also in some parts of statistics. But the idea is to give you an idea as a definition of expected value. Expected value is an average of a random variable, to roughly speaking. So do you agree? So when I wrote this, the expected value will be the value that the random variable takes. Once you are able to do this, it will be very clear into the PMF of the random variable. Do you agree? Over all the values the random variable takes. This is what we have written. So it is 1 into 2 by 7 plus 2 into 1 by 7 plus 5 into 3 by 7 plus 7 into 1 by 7. It is matching our normal childhood definition of average also, isn't it? So it's just weighing the values the random variable takes by their corresponding probability. I'm just writing whatever I wrote here in terms of PMFs, which O3 just now told me. Okay. Good. Now, so if I ask you what is the expected value of a Bernoulli random variable, what is the expected value? This is how
So
you
it's
write.
P, I guess. P.
Okay, yeah. So how do I solve for it? So it's summation of x, p of x is equal to x. That means it is 1 into probability of x is equal to 1 plus 0 into probability of x is equal to 0. Do you agree? Which is nothing but probability of x is equal to 1 is equal to p. Okay. I guess that is okay. Now I'll tell you two things as a property of these expectations, and then we can go to more complicated distributions. So one property is a very important property known as linearity. If you have two random variables x and y, the sum of these random variables is equal to sum of these is equal to the sum of each separately. Okay, so the random variable x plus y has a expected value or mean as sum of individual expected values. Okay, so we'll show you why is it useful when I come to the binomial distribution thing. So why is this true? I'll give you just a like I'm seeing you're like not following the mathematics so well. So I'll give you a
One
Yeah.
question, Moinakta.
Yeah.
When we are saying x and y are random variables, I assume we understand that they are independent and independent.
They
Because
need
if they
not
were
be
dependent,
independent. That's the nice thing about it. X and Y need not be independent. There is no independence over here. It's general. I'll show you where independence will come in, but here it's not. But up to this, what is expected value is clear to you, right?
yes, what is an expected value is clear.
So okay, so let us consider if you're telling me it's independent, so why is it not required? Say Z is a random variable as a sum of two random variables. Okay, again, to orient you, what is the sum of two random variables? It's also a random variable. Why? Because each of this, for every event, X will output one number, Y will output another number. So Z in turn will output the sum of those two, right? So what does this actually mean? Z of omega is X of omega plus Y of omega, right? This is what it actually means. So if you have head, say X maps it to 0 and 1, Y maps it to 0 and 2. So if you have the same event, so you have a head, so it will be 1 plus 2 equal to 3. Something like that will happen. So he's telling you, I'm telling you, why is it not required to be independent? The idea is, so you consider all these events, right? So you have events here, right? And you have numbers in this line. So you have X that maps it to one of these numbers and Y maps it to one of these numbers. Say another set. So on expectation, even if you have X plus Y, it will be sum of these two. Why? Because you will weigh each of these elements differently, right? So for example, if X is mapping to an event to 0 and 1, sample space to 0, 1, and Y is mapping to 2, 3. So what will Z map to?
2,4, I guess.
So if they are this for the same event 0 and 1, let us consider that X of omega is 0 and X of omega 1 is 0 and X of omega Y of omega 1 is 1, 2. So it will map to 2 and 4, right? So what is the expected value of X if you take each to be P as the probability of success to be P? Even if I take dependent variables, you will see it is true in this case. So it will be X of 0 is P, 1 minus P, P and 1 minus P. So do you agree this will be 1 minus P? And expected value of Y will be someone? What would be the expected value of Y?
3 minus P.
3 into 3,
Okay.
3 to 1 minus P.
2P plus 3 into 1 minus.
Correct. This is 3 minus P, right? Yes or no? Agreed? I think you told me the answer. What is the value of Z then? Expected value of Z? Yeah, go ahead.
Expected value of Z computes to about 4 minus 2P.
So it is 2P plus 4 into 1 minus P. Yes or no?
Yes.
So this is 4 minus 2P. Is it equal to the sum of these two, even if they are dependent totally?
Yes, I see now.
Why is the case? I'm showing you now mathematically. Just look at it. So if you write expected value of Z, someone else please tell me what would be the expected value of Z in terms of the definition. Do you agree this is Z into probability Z is equal to Z? Yes or no? over all possible values of Z. That's what I wrote here. Yes or no? A simple definition. Okay. So what is Z internally defined as?
X plus y.
So it's X plus Y equal to small z. Is this probability? Okay. Now there can be any combination of X plus Y that will give you Z. So how can you break it up? Let's take small x plus y equal to Z. Okay. Such that X is equal to X and Y equal to Y occurs. And here it is not 1, 1. Remember that. Your pre-image can be anything. So for example, I'll write it as, I can write Z now. So remember, I'm overloading notation. The capital X's are the random variables and the small x's are the values, actual values. So you may be confused. What am I writing here? So this is the value. It can be 0, 1, and so on. And this is the random variable taking that value. Okay. So this small z will be X plus Y into probability of, I'm cheating a little bit. I need to define in terms of the events, but just to let you know intuitively, that means it is all the combinations of X plus Y, X comma Y, such that Z is equal to small z. Is it okay? Is this conversion okay or not? So a sum is linear. What does this mean? So by law of total probability, what will happen? Here, see, this is not dependent on Y. So what will happen to Y if I sum over all the Y's?
It will become 1.
So Y will vanish, right? Similarly, here X will vanish. Whatever, what did I say? Probability of A is, if probability of A is sum over all I, A intersection AI, then it is, this is the law of total probability. Yes or no? I taught you last day. This will turn out to be X into probability of Px is equal to X plus Y, probability of Y is equal to Y, which is expected value of X plus expected value of Y. Is it clear?
So what we are saying is that since we're summing over all the values of y, so at
Correct.
the end,
And there is,
y
and the outer sum is not dependent on Y at all. So you can just, so you can take X out, right? So if you write a two summations here, I write in terms of X and Y.
Basically, you are breaking it up, right, in terms of X and Y.
Correct. That's a law of total probability. Y will give you all those sums, which is independent, which is the intersection with X. You will get all those events. They're mutually exclusive events, right?
Yeah.
Correct. So this X is independent of Y. I'll bring this X here. So you will get this sum. So mutually exclusive events, Y will vanish. Yes or no? I wrote this statement once again. Over Y and over X. This Y will come out. Did you understand? This simple constant pulling out. You're pulling out constants from a summation. There's nothing else. Okay. So this will be very useful. I'll give you an example and then you'll understand, you'll appreciate it. And slowly you don't stay with me and when there is doubt, you ask. But please revise, go back and revise. You need to get accustomed to understanding what is capital X, that is the random variable, what is the small x, that is the values the random variable is taking. Okay. And the second thing is known as the LOTUS or the law of unconscious statistician. When someone falls unconscious, they write laws like this, and therefore it's named as law of the unconscious statistician. What does it say? Any function of a random variable can be just written as this way. For k in I, whatever you're writing, okay? All the values that k takes. So why can anyone tell me why is this true? Both by intuition and by mathematics. So let us, whenever this type of things are given to you, you have to write it this way. Y is equal to, say, g of x. Do you agree? The g is a function that maps from R to R. Okay, it's a normal function. Okay, so so expected value of
I to R
gx,
most probably.
yeah, here are I to R, but in general it can be R to R also. You can only map to I in any case, right? I to some countable set C. You cannot map I to some uncountable set, isn't it? One side is a countable set, the function can only map to lesser or equal to values, right? This is a countable set. Anyways, so do you agree this is expected value of y will be y into probability of y equal to y? Yes or no? Over all the values y can take in the countable set C? Yes or no? Right? It's just the definition of expected value. Yes. So what will I write y as? Y is any y is small x. So if you take a value of, if x takes a value small x, your y will take a value small y. So I can write y is as gx and probability of g. See, the left hand side again is a random variable, but this is a value. This is a number. Now see, g of x is equal to y means, what is it? X is equal to g inverse y. Or probability of x is equal to, so x is equal to g inverse y. So is equal to x. And remember, these x need not be a single number, they can be sets when you're taking inverses. But it won't have a problem because those all will be clubbed together when you're summing over them. So anyways, for now, think of it as a 1-1 function, then there's no issue. Then when you understood that, draw the pebble world example and you will understand why it is. So the pebble is something like this. So the events, say 1, 2, 3, they can be mapped to some G can map them to 5 and 6. Again, O3 is the same example I'm writing here. Say 5 and 6, right? Say this 1 by 3, 1 by 3, and 1 by 3, where the probabilities of these. I'll give this example will help you. So O3, what will be the expected value of? Can you help me to find the expected value? So this is your G function and this is your X, whatever it outputs to. So what is the expected value of X? First tell me, what is the expected value of X?
X will be 1 into 1 by 3 plus 2 into 1 by 3 plus 3 into 1 by 3.
Good. So it is 2, right? Expected value is 2. Agreed?
Yes.
Now, do you agree that if G is a deterministic function, P of 5 will be 2 by 3 and 6 will be 1 by 3? Yes,
Yes.
or no?
Yes.
Yes. Yes.
Why it is the case? I'll show you now. So G of X can take values of 5 and 6. This is how you must write examples to convince yourselves. Then you will understand totally. So g of x is
means
5. Go ahead.
means I guess you mean that deterministic, that means both
All functions are always
transitions.
deterministic.
Yes.
Functions are never stochastic. Even a random variable is deterministic. So once an event occurs, it will always map to the same value. That's why I'm saying remember that event space in the back of your mind. Events are what is random. Nothing else is random. So I'm trying to do as slow as possible. I had planned many things, but I'll go very slow. I may cut off some of optimization to go deeper into probability. Like last time I had thought that people have understood and I taught like with a high level of mathematics. Now I want to show you like the basics levels so that you understand the basics and just not mug up things. I may cut down optimization and then go to machine learning directly, or I may cut down on linear algebra and go to machine learning directly. I'll do something like that, but probability you need to understand. So now tell me what is the expected value of gx? Like just compute and tell me. Just by seeing this pebble world. Do you agree this is 2 by 3 into 5 plus 6 into 1 by
5
3?
plus 6 into 1 by 3. Yes.
10 by 3 plus 2, which is 16 by 3. Agreed? This is I solved in by seeing just the pebble world. I can also solve it using the x is equal to x thing, this thing. Yes or no? Right?
Yes.
Yes.
So how can I solve? Let me see. G of x into probability of x is equal to small x. So let's take x is equal to small x, is that is x is equal to 1, right? So what will this sum up to be? G of 1 into probability x is equal to 1 plus g of 2 into probability x is equal to 2 plus g of 3 into probability of x is equal to 3 or whatever. What do you have? Yeah, 3. Right? What is the each probability half or 1 by 3? So g of 3 is 6. G of 2 is 5.
5.
G of 1 is 5.
5.
This is why keep this inverse as a function of as a set, not a. So you see here. So now I am getting some confidence in my teaching that you are responding. 16 by 3. Do you see they're both the same? So whenever you're doing the math, you can, if you're not getting it, try to get these examples in your head. Okay. So two important laws we found. One is the law of the unconscious statistician and one is the linearity of expectation. And I have not taught you any distribution yet. It's on any general distribution. I just gave you one example of a Bernoulli and then I taught you these two because we will be using these statistics all the time. This is the major idea. So statistics of this distribution is what is required. Say if you are told that your classroom has an average, so it's a uniformly distributed between 160 and 170. So if and I tell you what will be the average value, by intuition you will say 165. But here we'll try to see why is it 165. That's the idea, and we'll see many other different statistics as well. But these expectation has to be the basic thing that you need to understand. So we understood what is linearity of expectation and what is LOTUS. The second thing I will try to understand is how does a random variable shift over its mean? That is also called its variance. So as we saw, a random variable was taking many values and it had a mean. But the random variable will also vary across its mean. It will have some distribution, right? That is, it will have different PMFs, like just now O3 had pointed out. Where is that function? This is the function, right? And the mean turned out to be how much? Let us see how much the mean turned out to be. 2 by 7, 2 by 7, 4 by 7, 15 by 7, 9 by 7, and 26 by 7, I think. Right? Yeah, 26 by 7. 26 by 7 is how much? It's around some value of 4, right? So you have 1, 2, 5, and 7. So this is 3 point something. It should be around 4, right? So about its mean, what is the distribution? So you will see this has some probability, and what about its mean? How are the probability mass functions distributed? That is the idea. Okay, the mean is around 4 of the random variable. So, and what is the, how much does it vary across its mean is answered by its variance. Okay, how does that's the,
Dada, sorry to interrupt.
Yeah.
You said 4 has a probability that
4?
you are doing by making the graph
go
continuous.
again. You got your ball.
You said that 4 has some probability, the mean has some probability. So you are doing it by making the graph continuous.
There's no continuity here. The idea is 4 has no probability as of now. That is a mean. So if it is a continuous random variable, it will have a probability. But now the idea is, so what are the values the random variable can take? 1, 2, 5, and 7, right? It has no, 4 has no probability at all. It is 0. My idea is, how is it? Say 4, it is here, right? 4 is here. Yes or no?
Yes.
So it does not take the value of 4 as you are pointing out. Absolutely right. But the random variable has a variance across 4, right? It varies across 4. It is never 4. It is near 4. Yes or no? For example, in a coin toss, if you are having 50% as, say, in a fair coin, as a 50% as your probability, 0.5 as your probability of the expected value, right? Expected value is 0.5. But the random variable can be 0 or 1, isn't it? So how much does it vary across the mean is the idea. It will be more useful when you have continuous random variables. But here, that's the idea. So how, these values, how much does it vary across? So 1, 2, 4, 5, how much does it vary across 4? About 4. Did you understand?
Yes.
So for example, if you have this physics example of a rod, right, with a mass, center of mass being at the center, what would be the distribution of the, so if you pick up any element on this rod, what would be the distribution that you pick up around it? So if you will do questions like this, and you will see that it will be around half of these ranges. So if you select a point on this rod uniformly, so you will be only selecting on average around this region, around the mean. So that's something like that we'll do. We'll try to get the intuition right. So the intuition is, so if on average, if it is a continuous distribution, how much does it vary across the mean? Okay, even if it is not continuous, the random variables can vary across mean. Is it okay? I guess it is okay. It across the mean, how much it can change. So the variance is defined as, so can you see that expected value? So I'm telling you, so let me just write it at the end, so it will be easy to understand. So variance of x, if I define this as x minus expected value of x. Can you tell me what is the problem with this? This is the mean, mu, and how much does it vary? How much does the random variable vary across the random variable is this, and probability is this. Okay, how much does it vary across the mean? Can I define variance as this? Put a question mark. And if no, why?
Because when we are saying that expectation of a certain value of that, so it can be plus or minus, right?
There is no plus
So
minus. What did we calculate? Is expected value of something is constant or not?
yes, it's fixed.
Then it's expected value of c minus x minus c. Yes or no?
Yes, so it's expected value of x minus c.
Then by linearity of expectation, what is it? Expected value of x minus expected value of c.
C.
Which does, what does it mean? This is again c. And what is the expected value of a constant? A function that is always constant?
C.
C
The-
into probability of x is equal to x. For all x, C will take out probability of x is equal to x. This is equal to 1. Law of total probability, which is C. So C minus C is 0. It is always 0. So we cannot define this way. Right? Is it okay? So for E, we have to, why is it happening? Which is because C can be, as Partho was saying, the intuition was right. It can be either negative of C or positive of C with equal mass. So it can exist either side with 50% probability. That's why it is, the mean is 0. Right? If you subtract that from that, so you will get only 0. Right? So then how can we make it more meaningful? We can make it more meaningful by removing the sign. Say something like this. Now it will not, this problem will not occur, right? How much does it vary on magnitude is what we are trying to ask, right? If we see the direction also, it will go to 0. Okay. Now this is always, there is no negative positive, always positive. It can never go to 0. Agreed? How can I write the interior of this expectation? What can I expand this as?
X square minus 2x EX.
So this is defined as the variance.
বৈনাকদা ওটা প্লাস ই অফ এক্স হোল স্কয়ার হবে না?
Yeah. So minus 2 into expected value of. So again, remember, by linearity of expectation, right? Yes or no? Correct? So do you agree this will go, this is the constant can go out? Again, this is the constant can be removed. There is no expectation of a constant. Expectation of a constant is a constant. So you'll get expected value of x square minus yes or no? So this is two things here. We'll solve a question and it will become clear. So we have seen what is the expected, how we have defined variance. Now, someone of you will tell me for the Bernoulli random variable. Okay. Let us define it for the Bernoulli random variable and then we'll go to the other properties of this. Where is the Bernoulli? Yeah. Tell me. So we have found one thing. That is for the Bernoulli random variable, expected value of x is distributed as Bernoulli P. What is the expected value? P, right? Already defined? Already we calculated this. Now tell me what is the variance of x?
It will be e of x square minus e of x whole square. So
What is, so I know this already, it's p square, right?
yes, and that is p.
Why is it p? I want someone else to tell me. Go ahead, Brahmajit.
Just because x square we can x is either 0 or 1, so x square is also 0 or 1.
Correct. So what did we did see? So we did a what will we use here? Law of unconscious statistician, right? Yes or no? For all x, just now we proved, right? The value of the function is nothing but gx square, right? So you told me 1 squared into probability x is equal to 1 plus 0 squared probability x is equal to 0, which is equal to p. So your variance is p minus p squared, which is defined as p into q. Q is 1 minus p. But you see that, do you see variance is defined in terms of square of the random variable? So if it was a random variable was measuring height, your variance would be measuring height centimeter square. Yes or no? The units need not be maintained. Yes or no?
Yes, Madam.
So generally we report standard deviation, which is the root of the random variable variance. This is for a Bernoulli random variable. Okay. Now someone of you will tell me these properties of the random variable, variance of a constant into x. How do I solve? Variance of a constant into x is
C square into variance of x.
C squared into variance of x.
correct.
Yes.
Correct, Siddharth. So what is the step? So expected value of cx whole square minus expected value of cx whole square. Yes or no?
Yes.
So what is cx again? C square expected value of x whole square. Yes or no? C is a constant. I have already shown that if there is a constant multiplication, I can just take out the constant from the expectation.
Yes, ma'am.
Similarly here it's c squared x squared. Again I can take out the constant, so it's c squared expected value of x squared minus expected value of x whole square, which is c square variance of x. Correct?
Yes, madam.
Good. And the second property is, it will be useful in Bernoulli binomial distribution. X plus y are two random variables. What is the variance of x plus y? Again, from the definition, it is expected value of x plus y whole squared minus expected value of x plus expected value of y whole square. Yes or no? Is it right? Right. Let me just write this variance of z is equal to expected value of z square minus expected value of z whole square, which is, if you write z as x plus y. So you can write z is equal to the expected value of z is equal to expected value of x plus expected value of y. Yes or no? It is okay. So now do the calculations. What will it turn out to be? X square plus y square plus 2xy minus expected value of x whole square minus expected value of y square minus 2 into expected value of x into expected value of y. Is it okay?
Yes.
Okay, so I'll get expected value of x square minus expected value of x whole squared plus expected value of y squared minus expected value of y whole square plus expected value of xy minus expected value of. We'll come to this term later, but for the time being, let's keep in moment. So this is, do you agree, variance of x?
Yes.
Yes.
This is variance of y, and this is defined as covariance plus 2 into covariance of xy. What does that mean? Let us see. Covariance is how x and y vary with one another. In other words,
For independent, they will be 0, right?
exactly, that's the idea. Just see. So covariance is defined as covariance of xy. We'll look at it in detail when we do joint distribution, but let us see what is covariance for intuitively. It is defined as expected value of x minus expected value of x, y minus expected value of y. So if they are correlated, or that is, you hear this type all the time. If this random variable one increases and other also increases, this is x and y, you will have something as positive. This will be greater than 0. Do you agree this product will be positive if x increases and y increases? Similarly, if x increases and y decreases, what will have? You will have, exactly, you will have a negative correlation, less than 0. Anyways, so but as Hussein was telling me, what is expected value of x minus expected value of xy if x comma y are independent? This is all we need now. What will it be? What is expected value of xy if they are independent?
Expected value of x into expected value of y.
Why? Why? I don't know all this formula. Tell me how to do. How to do this? Say again.
So this is xy into
Probability of x is equal to x into y
p,
equal to
x
1.
equal to x into p of y equals to y.
Very good. So they are independent now. By independence, what do I mean? In two random variables are independent if the joint distribution can be written in terms of their marginal. This is joint
Yes.
distribution. We'll see it in details, but this is called a joint distribution. These are called marginals. Now, do you agree with the sums can be separated out? That is, x into probability of x is equal to x into y into probability of y equal to y. Yes or no? Because they are independent, each does not depend on the other. So you get expected value of x into expected value of y. So covariance of xy is equal to 0, right? If xy independent. I'll give you a homework. Show that if covariance of xy equal to 0, x comma y need not be independent. That is, x independent y implies covariance of xy equal to 0, not the other way. Okay, this is your homework. Try to find a counter example. I hope you know how to do proofs where it is we have to show no. That is, you need to show a counter example. Very simple. Just think about it for 1-2 minutes. You'll get the counter example. No issues. Okay. Now we have got all the tools in the repository to solve the questions that I have now for you. So I have proved this. So if it is minus, you'll get negative. If it is plus, you'll get positive. Here, anyways, we have solved. All these things are done. Now we'll tell what is a binomial distribution. Now we are entering into the real random variables. Till now, we were just defining the necessary operations to be done on random variables. So what is a Bernoulli random variable? It is defined as a sum of n independent and identically distributed Bernoulli random variables. Again, what does that mean? A random variable y is called binomial NP if y is x1 plus x2 plus x3 dot 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 xn. What does that mean? It is number of successes in n trials. If each trial is IIT. Okay, is the motivation clear? If each trial is IID, number of successes, right? Now, somebody can tell me what do these random variable, what values do they take? X1 to xn?
0 or 1.
Very good. So what values can y take?
it is 0 or some positive integer m.
Up to
All positive
Whole
integers.
numbers. A
all
whole
numbers.
number.
Up
All
to n.
numbers.
A whole
Very
0
number.
to n.
To n.
Very good. Very good, Othridge. I hope you're understanding the concept now. So, okay. So y is equal to the sum of these random variables xi. I is equal to 1 to n. So they can take between values. So they are. So first tell me what is the sample space of this random variable. If x's sample space was sigma, or say success and failure. Success and failure was being mapped to 0 and 1. So what is the sample space of y? If I ask you,
Number of successes. 0
no,
is
sample
1
space.
is up to
Sample space. Sample space of y. What will y map to?
means 0 success or 1 success and sort of.
No. This is your sample space. Again, you're not understanding the thing. You have two coin tosses. What is your sample space? Head, 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 tail. Tail, head, tail, tail, right? This is why I'm telling keep that idea of sample space in the back of your mind. So it's you're selecting n of these. So you have n trials, right? Each can be success or failure, right?
Yes.
So it can be a series of S by a C and of F, any permutation? Yes or no?
Yes.
Correct. So for a particular number of, so what do you define this? Say if you are told, say let us take, now since you have understood, let us take all the, so Bernoulli P, I'll just solve at the end, binomial P. So if I tell, so sample space you understood, right? It is the, so y is success, failure, and n of these success, failure trials. 2, 0, 1, 2, 3, and n. So it is going to sum the number of successes, isn't it? I hope that is clear. Let us see. So probability of, say, y is equal to k means, can you tell me what does this y equal to k mean? First tell me if k less than 0, what is the probability, and k less the greater than n, or k greater than n? 0.
0.
Good.
0.
Now if k is between 0 and n, what is the probability? Why am I telling this? Because here is this sample space which will come into play. You need not use a sample space. You can see this equation and tell me, but also you can use a sample space if you are really thinking about it. What is the probability of k successes, right?
Yes.
This is the idea. So I have this equation y equal to 1 to xn. I want k of this n numbers to be 1 and n minus k to be 0. Yes or no? So I want S, S, F, F, S, S, and so on. K, S, and n minus k, F. Yes or no? For 0, or here 1, and here 0. Yes or no?
Yes.
So for a particular combination, what is the probability?
So first I have to choose k out of the n.
No, for 1. If I give you 1, no, don't give me all learned things, what you have learned, memorized. If you have said this is one particular sequence of events, what is the probability of the sequence of events?
P to the power k.
1 minus.
Good. P to the power k into 1 minus p to the power n minus k. They're identical and IID. I hope it is clear. So you will just multiply p 1 minus p. I have taught you last day, and so on. Law of multiplication. This is your probability. But now, do you agree that it can be any permutations of these? Yes or no? It can be any permutation of this. So how many permutations are possible again by last day's class?
N factorial by k factorial into n minus k factorial.
Good. N factorial is number of permutations by number of zeros. That is n minus k into k factorial. Is it clear, Partho?
Yes.
So you will have n choose k, p to the power k, 1 minus p to the power n minus k. This is defined as the PDF. Okay. Nice. Now, I would ask you, sorry. Now we'll define something called as a CDF. That is cumulative distribution function. It will be required in the continuous case, but let us keep it defined here. CDF. Or let us do the expectation first. Simple things first. So what would be the expected value of y? Anyone? Now all the fruits that all the hard work that we have done will bear fruit. Tell me. What is the expected value of y? It should be done within seconds.
0 into p of 0 plus nck into p, that one.
No. There, you will. No, I'm not going to do this. You're right. You can do that. 0 into probability y equal to 0 plus y into probability y is equal to 1 and so on. You can do the binomial theorem and get the value, but I'll not do that. How do I do it without using? I've taught you a theorem just now. Very important theorem I taught. And that's the fundamental question you'll be asked all the time, everywhere. And you'll be using it, leave alone asked. This I'll not do. This is calculation. Without calculation, how can I do? So what is y defined as? Tell me. Yes or no?
Yes.
Yes.
So now, by linearity of expectation, what can I write?
E of x1
E of
plus E of
x1 plus E of
x2.
x2 plus.
You just take the summation out.
Yes. And since it is IID, probability of xi is equal to probability of.
equal.
This is called the fundamental bridge. So if you can write it in terms, I'll give you in assignment. Last time I had given, Brahmujit may remember, that if you can write things in terms of even dependent random variables and as sum of those, then you can always use the sum of linearity. And then it is n into p, yes or no? Do you agree?
Yes.
What would be the variance of y? Just to be clear, this is you must remember this is a Bernoulli p, each of these xi. Okay. So what is variance of y? Again, I proved this. You may be thinking that time that what I'm doing is not useful. But tell me, what is the variance of y? Again, variance of I equal to 1 to n. Yes or no?
The NPQ, because it's coming as NT minus NT squared.
So we had, yes, we got PQ as the variance of xi's, right? Of binomial.
Yes.
So now I have
And since
NPQ.
they're independent, we can add them. Yes.
Independent means covariance of xi xj is 0 for all ij. Yes or no? So I can just add them. That third term will no longer be there. So sigma of y is root npk. Okay. I hope that is okay. That comes to the end of binomial distributions. Now I have defined my own distribution, which we'll be now seeing. Now you will have to tell me, I have a function given to you which says that f of x is floor of x by 6. You have to define its PDF. What is f of x? It is the CDF. I'll write it. So I thought I will define it before, but let me define it now. So probability of x less than equal to small x is known as the cumulative distribution function. Or the CDF. Okay. Do you agree it is going to be always an increasing function? Always increasing?
Yes.
Yes.
Why?
Yes.
We approach 1. As the value of small x increases, we approach 1.
Correct, we'll do that. But why is it always increasing?
Because the
Okay, go ahead, Partho.
because the probabilities get added up one by one, because if I take x less than equal to x and if I take x less than
Correct.
equal to x plus 1, then it is basically plus in
Okay, if I
plus
take x plus,
p of
if I write x plus delta, right?
yes,
I can write probability of x less than equal to x plus probability of
plus x equal to delta.
right.
Yes.
Yeah. So you see, if I remove this is greater, right? For delta greater than 0. So it's an increasing function. Anyways, so let us take this example and then it will be this CDF thing is also going to be clear to you. And then we can stop after doing Poisson distribution. I thought I'll do a little bit of continuous also, but I don't think I'll get time. Let's go slowly. Okay. So the question is, say f of x is ceiling of x or floor of x by 6, right? What is PMF of x given? What is the PMF of x? Now, can anyone tell me what are the values that x yeah, go ahead.
Now, I was going to ask that. What are the values which x can take?
Now that you have to tell me.
So it's
Can anyone,
minus
can
infinity to
anyone tell
infinity.
me? X can take minus infinity to infinity, but the idea is this is defined for a region. For which region is it defined? And it should be 0 otherwise. Or 1 and similarly 0. So its CDF has to be defined for all values, minus infinity to infinity. That's the beauty of CDF. Even if it is not defined for
It's
a PDF.
defined for all the positive numbers.
X
Let us
can take
see.
values from 0 to 3. Else it has to be 0.
3, how did you get? 6 it should be, no? Let us see, let us see. What does this function look like? Let us see how does the function look like. So this is f of x and this is x, right?
Dada, this is the CDF you gave or the original
Correct.
function?
I gave the CDF. I
Is
want
it
you to
CDF?
understand what is a CDF. That's why I want to show you how CDFs are built in the reverse order. The positive straight ordered, like I could have just told you that I'll give you a homework only. Write the CDF. So number 2 would be write the CDF of, where was that number written? Where I wrote variance. Yeah. This is one. Number two, write CDF of Bernoulli, binomial and Bernoulli. Please try to solve these questions and then it will be like everything will be like clear, crystal clear. You will write the CDF of Bernoulli and binomial. It will be like you will be understanding. But here I'll be showing you the reverse. I have given you the CDF. I want you to find the PMF. I'm telling you it is discrete. And I'll show you why is it discrete. And we'll derive one interesting property also from this. Can you tell me how does this function look like? If you understood. So you, Uthrij, how will it look like?
Mm, I'm not sure, but one operation I did was that since probability should be less than equals to 1, so floor of x must be less than equals to 6.
Very good. Very good. Very good. So it should be up to 6, but that is the values where the PMF can take, right?
Yes.
So if the value is
Yes.
between 0 and 1, say x is between 0 and 1, right? Do you agree it is going to be 0?
Yes.
Yes.
As soon as it goes not 1, 1 should be excluded, sorry. As soon as it goes to, what am I writing? Yeah, it should be as soon as it goes to 1. Do you agree? Up to 2, it will be 1 by 6. Correct or not?
Yes.
Even if x is less than 1, minus infinity, from minus infinity to 1, all values will have the same 0 probability, yes or no? This is the beauty of CDF. There will be step functions for discrete distributions. For discrete is equal to step function, and it is defined everywhere. Do you see if it is x is say minus 3? Do you agree that your f has to be defined? This is x is less than 0. Agreed? Because you cannot have negative probability, right? So CDF cannot be negative. You have to float it to 0.
Yes.
So that is the definition I wanted from you. And 1 if it is greater than 6 as Othrish told me. Yes or no? Right? Right? Is this okay? I have defined for everything. Let us see. So at 1, it will go to 1 by 6. Do you agree? And it will stay at 1 by 6 up to 2. Correct or not?
Yes.
Yes.
And then it will go to
1 by 3.
2 by 6. Correct. And it will stay there for
Up to 3.
correct. And like this, it will go to 6. It will reach 1. And then it will stay in 1, right? Forever.
Yes.
So you see it's an increasing function or not? Here also you're getting an increasing function as expected. So if I tell you define, so do you see you have all the masses present at 1, at 2. So let us draw it here, 2, then at 3, and then at 6. Do you agree? All the mass is sort of present in these points. So do you agree that probability of x is equal to 1 is equal to probability of x is equal to 2 dot 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 probability of x is equal to 6 is 1 by 6? Yes or no? At every step you're going one step up, isn't it? See at 1, when I reached 1, so if I say probability of x is equal to 1, isn't it?
Yes. Yes.
What does that mean? I can write it as probability of x less than equal to 1 minus probability of x less than equal to 0.
Means it is basically f of x plus 1 minus f of x.
Correct. f of x plus 1 minus f of x. Let us see what is that thing over here. So f of x is equal at 1. Do you see that it is shifting to 1 by 6? That's what is happening, right? At 1, it shifted to 1 by 6. 2, it shifted to 1 by 6, right? 2 by 6. That means the probability of 2 was 1 by 6 again. At 1.99, the probability of f less than equal to 1.99 was again 1 by 6, indicating x is equal to 1 is the event, right? So for a discrete distribution, you can write f of x plus 1. So if you are told to find probability of x is equal to small x, so you can write f of x minus f of x minus 1 if x is integer, right? Yes or no? Or at all the jumps, you can just check, right? Is this clear, everyone? So I asked you what is this? This is an example of a die roll. So isn't it? So 1, 2, 3, 4, 5, 6 all can occur with 1 by 6 probability. That's the idea. Okay. I guess that's clear. Finally, let's complete today's session with what is known as a Poisson distribution. And then we can do continuous distributions next day. So a Poisson distribution is a generalized version of a binomial distribution. Generalized case of a binomial. Okay. Generalized case of a binomial where it is right here only. N goes to infinity and P goes to 0. And NP goes to lambda. Okay. Some constant lambda. I'll give you an example. For example, number of emails per year, emails per hour, right? So because number of people sending, n be the number of people, that can be infinite, very, very large number of people sending me, and each sending me with a probability p can be very close to 0. Yes or no? In these cases, it's not useful to use a bind. So number of emails I receive is not going to be useful, right? It's not going to be useful for me to use the binomial distributions. Do you understand? Instead I could have a simpler solution to it. I'll show you why. First, let us do a simple question and then we'll do. So the probability of x is equal to k in this case is defined as e to the power minus lambda, lambda to the power k by k factorial. Okay. It is the definition, and I'll show you why is this definition after I have solved all the like these 3 problems given here, so that you get the feel of the distribution first. So give me another example. Say you have a cookie dough. So number of cookies, number of choco chip in each centimeter square of the dough. Do you understand? So you can have many, if it's a large bakery, you can have a huge cookie dough, right? Similarly, number of people arriving at a shop, number of people arriving at a grocery shop. The entire locality cannot appear at the grocery shop, but each with a probability very low, p equal to 0, very close to 0. Okay. And then what do you say about the, similarly in computer science, you may, or CS students, number of processes arriving at a particular time, you will be, or number of packets sent in an Aloha protocol. All these things would be over a network, would all be. So Aloha protocol is also over Poisson distribution. So number of packets sent in a channel without any communication between them. So if everybody sends a channel, there will be a collision. So the probability of the collision is defined by this Poisson distribution. Okay. Any doubt regarding the intuition of this distribution? And then I can go to the math. Yeah, go ahead, Utrecht. You are unmuted.
Yes, means the probability that you are talking here is, suppose for the second example, if I consider, so there can be many people in the neighborhood, but for a particular day, few of them will arrive. So in that
Correct. At a
case,
particular time, you can take a particular hour. Only a few of them can arrive. Not all will not arrive. So everybody has little probability of arriving.
Okay, fine.
And there can be many people. Like also in a raindrops, you can take. The raindrops can be very, very large number. So in a particular, if you put a handkerchief, what is the number of raindrops you're going to get is an example. Right. So let us first example, if you have understood, tell me what would be the probability that, so show that it is a valid PMF. So what is the, how can you show it's a valid PMF? Validity of the PMF?
If it's summation, means over all
value.
possible values of x is 1.
So all values of x is up to infinity, right? Do you agree? Everyone who understood this problem's intuition, because n can be infinity, so your k can also go up to infinity. Do you agree?
Moinagda,
Yeah.
Just a sec, means I am just going to a bit earlier stage. That is that the intuitions you were speaking of over there in a choco chip cookie, the per centimeter square of length. So it can, the n can be very large in this case.
Yeah.
So can you please tell me why the p goes to 0? I couldn't understand this half
Because
over
you
here.
have fixed number of choco chip. If they will not give you infinite choco chip, na?
Yes.
So if you have fixed number of choco chip and you have very large dough, what is the probability of a centimeter square you will get a?
Oh, acha. Yes.
This is the idea. If you have one constraint thing, that is why the product of n and 2 into p goes to lambda. That is the number of expected value of number of choco chip. Okay.
Yes, it means one gets very high and one gets very low. So everything comes at a equilibrium in this case.
In this case, it does. So let us see if as he was telling me, Partho was telling me, ki, the sum must go to 1. So what is this value? From your class 12, 11 Taylor series? What is this? What is this sum? What does this series add up to? E to the power x, right?
The Taylor expansion of e to the power x.
Yeah. So if you f0 plus f dash 0x plus f double dash 0 x square by 2 factorial and so on. Correct. So this is here I'll put x is equal to lambda. So this is e to the power minus lambda into the e to the power lambda is equal to 1. Agreed? Good. If you have understood, the second question is find the expected value of x. What is the expected value of x? If you have been following me all this while, what would be, how will I write this expected value of x? Say k equal to 0 to infinity, what would be the k into
p of x equal to k.
That is k into e to the power minus lambda to the power k by k factorial. Variance would be homework for you. Please try it out. I will not do it. It's the same question. I don't do it twice. Okay. So how will I solve this? Any idea? I think this was there in your, like, this type of solution you could like do in class 11 and 12.
Yes.
Yeah.
Yes,
How do
we'll
you
take
solve
the
this
d to
sum?
the power
Like
It will take the e to the power minus lambda out.
X. No, how lambda you will take, you'll get constant. What are you saying? If you take constant, then the derivative will become 0. Are you seeing that there is a k here and there is a k here? You need to take derivative somehow. This is those sums you used to do in series summations in 11 and 12.
or without derivatives we can do, I think.
You
Just
can
cancel.
do.
We can cancel k and k factorial, then we are left with lambda k to the power minus 1 by k minus 1 factorial. So that
What?
again is a derivative expansion.
Oh yes, you can do that, but
If we
correct.
take lambda and e to the power of minus lambda out, then we can do it.
Lambda and e to the power minus lambda out.
Lambda, yes.
Yeah, that you
Common,
can take.
common.
Yeah, that is also a derivative only, na. I'll show you why. 1 plus. So
If
do
we
you agree?
start the sum from k equals to 1.
Correct. All of you are right. I'll just do it myself, my way. And then you like these are the same ways of doing the same thing. You'll see why. So do you understand this is equal to x to the power x to the power k by k factorial? Yes or no? This we already know. This is the Taylor expansion. If I take a derivative on both sides, what will I get? K x to the power k minus 1 by k factorial. Yes or no? As O3 told me, from 1 to infinity, right?
Yes.
Okay. So now this is e to the power x is also e to the power x only derivative. I multiply x on both sides. So what do I get? K equal to 1 to infinity k x to the power k by k factorial. Yes or no? Is this okay? Understood, no? This is nothing, not very difficult. I just multiplied x on both sides. Okay.
Yes.
Now what? Now what will I do to bring the form above? I can also write 0, right? Because 0 will k will make it 0 will go to 0 only. I have no problem writing 0 also, right? Because k is become multiplied. Multiplied by 0 would ensure that it is 0, right? And 0 factorial is 1. Correct?
Yes, so we are going for lambda k x equals to lambda. That
Very
we will
good.
put.
Now you will put x lambda e to the power lambda is equal to lambda or k lambda to the power k by k factorial. And then in our question we had this normalizing term e to the power minus lambda multiplied on both sides. So do you see lambda is the expected value? Yes or no? Lambda will be the expected value. Similarly, most probably your variance will also be equal to lambda. Just check. This is your homework. Variance also would be equal to lambda. I am not exactly remembering is it lambda or lambda square, but check. Anyways, but now to end today's session, I told you ki n goes to infinity, then this happens. So I initially thought of giving this as the homework, but I thought this is makes more sense to solve it now compared to this variance thing. So tell me, how will I show that the binomial converges to Poisson? This will give you the entire picture and connect everything. So Bernoulli, Poisson, and by Bernoulli, Poisson, and binomial, everything will be connected. So how will I solve this? Any idea? So LHS, what can I write? N factorial by n minus k factorial into k factorial into p to the power k into 1 minus p to the power n minus k. Yes or no? And I will take limit n tends to infinity, right? Now it's a limit problem. Any idea how will I solve it?
I'll take n out from the lower term, I guess.
N out. N to is infinity. How can you take that out? K you can take out.
No.
So k less than infinity for any finite k, this will be true. Let us see why. So the numerator will be n into n minus 1 dot 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 n into k plus 1. Yes or no? By k factorial into p to the power k into n minus 1 minus p to the power n minus k. Yes or no? Right? Is this okay? I hope this is okay. I just did algebra. Now, do you agree n comma n minus 1 dot 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 n minus k plus 1 all tends to n if it n tends to infinity? Yes or no?
Yes.
Yes.
So I can write n p to the power k into 1 minus p to the power n minus k by k factorial. Right? Limit n tends to infinity. This I have already defined. Np goes to lambda as n tends to infinity. So I can write lambda to the power k by k factorial. Limit n tends to infinity. 1 minus p to the power n. Again, this k I can just ignore. Yes or no? Now, anyone? How to solve this? It is that form of your equation, right? 1 plus x to the power infinity, 1 plus 0 to the power infinity form, right? You remember this form? You have to take log and then solve. So for example, limit n tends to infinity. If you had 1 plus f of x by 1 by g of x, if fx goes to 0 and gx goes to 0, you remember what does it turn out to be? E to the power limit x tends to infinity fx by gx. Yes or no? You just take log and take L'Hopital, you will get this. Isn't it? This is standard Emil
Yes.
Khanna formula.
Yes.
Correct. So here it is 0, here it is infinity. Right? So what will you get? You'll get e to the power of limit n tends to infinity minus np. Simple. This can be even given in board exams, not a difficult question. E to the power minus lambda, lambda to the power k by k factorial. Isn't it? Done. So you see, if n tends to infinity and product becomes constant, what do you get? You get a Poisson distribution from a Bernoulli itself, binomial distribution itself. Is it okay? With that, I'll stop. We have done discrete distributions. And yeah.
Dada, could you once more describe the terms of the Poisson distribution?
Terms as in?
The meaning of that n tends to infinity and p tends to 0 and np tends limit n tends to infinity, np tends to
So
lambda.
n is the number of options, number of experiments you do, right?
Sir, I'm saying in terms of, let's say, the Aloha method, Aloha process. Then
What
if I say n is Aloha, a pure Aloha.
Aloha
Then
process. So n is the
n is
number of packets.
that has been generated.
Correct.
What's p? Number of
So
questions.
my question is not in terms of Aloha, is the n is the probability, n is the, say you have n nodes, right? N nodes in the channel. So each node has a probability of, so there are large number of nodes. In the internet, you have large number of nodes. That's why you come up with such modified algorithms, change Aloha and so on, slotted Aloha and so on. But the idea is, if you do a plain Aloha protocol, you will see is each node has a probability P of generating a packet at a particular time. Correct? So the product, and there are n number of nodes. So NP is the constant. So at a particular moment in time, NP would be some lambda.
Yes. And if the number of the stations becomes infinity, almost infinity, and then it will mean that all of them are generating packets and they will all lead to collisions, and that's why the P is tending to 0.
No. The collisions happen after that. P is the probability that a station generates the packet. Okay.
No, I mean, I'm saying why is if n tends to infinity, P is tending to 0.
So for your question only, I'm going to do it now. Say for example, when will there be a collision? When probability of x greater than 1 equal to 1. Right? Or it is equal to 1 minus probability x is equal to 0, right? If there is no packet being generated, then if you generate a packet, correct. So what is this? 1 minus e to the power minus lambda to the power 0 by 0 factorial, which is 1 minus e to the power minus lambda. Right?
Yes.
If you are a station, all the other stations is what you are seeing. You are wanting to send. But the rest of the stations have a probability of by the Poisson distribution. Yeah, P of 0. If no one is sending at a particular time, your packet will be sent.
Yes.
Understood?
Dada, one small question.
Yeah.
Yeah, in the beginning you were telling about deterministic and stochastic functions. So can you tell in brief?
Let's see. So did you understand the go back, read the concept of random variable first, what I explained. See multiple times, give some effort, and we have one day in between. So look at that. So idea is random variable is a function. Okay. Random variable is a function that maps from the event space to a real number line. Okay. Always remember this. So what is the randomness in an experiment? It's the experiment itself, right? So head, if you toss a coin, the head or the tail is the randomness, right? Yes or no? So once you get the outcome of the experiment, then only you can use the random variable. Once you get the outcome of the experiment, you use the random variable, so random variable is always constant. So head will always be mapped to 1. 0 will always be mapped to, tail will always be mapped to 0, and so on. Understood?
Yes.
So x is a function. Functions are always like normal functions are always deterministic. You can have stochastic functions that are different thing, but normal functions are always deterministic because it's a mapping from one set to the other, right? Similarly, if you have functions of random variables in themselves, they are like composition of functions, right? So as I think you are confused about the you have understood how to compute the thing, but you're trying to understand what is the background intuition, right? You're trying to understand in terms of random variables and the event space, isn't it?
No, actually, deterministic and stochastic, those terms meaning and how they are
okay. Deterministic is when you have a function x, right? And there is a that maps to some output in the range set. Okay. This is a deterministic. Functions are deterministic only. As if I give a particular a, it will always output only 1. It will not output 0. Okay. It will not give me half probability, half times I'm giving 1, half and times I'm giving 0. That will not happen. Okay. That is deterministic.
Yes.
Stochastic is the outcome. So you have a sample space, E1, E2, En. These are outcomes of the random experiment. Outcomes of the random experiment. This is what is stochastic. Okay, this is where stochasticity comes in, or randomness comes in. Randomness is equal to stochasticity. Sorry for the term I did not mention. Okay. So head and tail, if I'm doing that experiment, it is not deterministic. It can be half times, or with p probability it can be head, with p 1 minus p probability it can be tail. Yes or no? That is the non-stochasticity. That is the stochasticity. And once you get the head and tail, the random variable is always deterministic. As in the output of the random variable is always going to be 1 or 0. Once you have got the output of the experiment. Okay.
Yes, understood.
And similarly, if you have a function of a random variable, is nothing but a composition. Like same as g of f is same as, if you write it g of f in normal cases, it's same as g of x. X is the random variable, is also a function, right? It's a composition. If you really want to understand what it exactly means, right? So what I will tell you to do is do these questions, try to understand what is the notation I'm using. So this notation is what is important. So the notation probability x is equal to x, because this will get more complicated as we go forward in machine learning, in continuous random variables, it will become more complicated. So try to understand what is this small x, what is this capital X. I know it is very difficult to do it in the first class. People who have followed till now, I think you have done 90% of the job. Next is you have to just go back and look at these notation. Take you your time, replay the video and look at it. Okay, I'll upload the video instantly on YouTube. You can look at it on in your leisure. Okay, I'll stop recording with that.